So we have this big red machine, Iron Byron, drive 10 golf balls from each of our 4 manufacturers, and then we measure how far each golf ball flew. And here is what we get. So, what is the best golf ball? The first thing you will notice is that all of these data points are a little hard to read. They're difficult to compare. At the very least, it takes you a little time to look through each column, assemble them in your brain, and then make a judgment call about which brand is best. This raises the question then, how can we organize and summarize these golf ball data in a way that better shows which golf ball flies the furthest? What we have just discovered is the problem with raw data. Those data in the table are raw. They are just as we collected them, but they are not ready to be served up to the public. They are too difficult to interpret in that form. Just like if we have raw meat and raw vegetables, we need to prepare them before they are served. And we will do the same thing with our data. As scientists, we will prepare them to be served up to colleagues or to the public for scientific consumption. I need to make an important point here. I'm using this metaphor of food preparation, but I do not mean to suggest that we are cooking the books or cooking the data in a negative connotation. We're not making things up. We are not presenting only the data that tell us what we want to hear. We are preparing the raw data using established techniques that are transparent so that anyone else can see exactly what we did. We are making the data easier to understand, but preserving the integrity of the data. We want people to be able to make well-informed decisions based upon what we find. Now, there are 2 ways that we can serve up these data. The first is with a picture, called a graphical display. The benefit of a graphical display is that it shows the shape of our data. For instance, with a histogram, we can tell how closely the shape of our data match a normal curve. In this case, not so well. We will learn how histograms, box plots, and stem and leaf diagrams can be used to graphically display our data to make them easier to comprehend. A second way that we can serve up our raw data is with a numeric summary. For instance, we may want to know how many male and how many female students answered our survey. Perhaps we want to know what was the average age of all of our participants. Or perhaps we want to use both of these variables and examine the average age of males along with the average age for females. In each of these examples, we are looking for a number that tells us something about the center of our data. We can use measures like the mean, median, and mode to find out what numbers are most representative of all of our data. These are called measures of central tendency, and they tell us where the center of our data tend to be. We also want to know about the dispersion of our data. How spread out are the scores? The same average has very different meanings when the rest of the scores are very spread apart instead of being very close together. If we survey some people and we find that their average age is 20, that is more useful when we have surveyed college students, and 89% of them are between the ages of 17 and 22 years old. Most of our survey participants are very close to the age of 20. But if we survey people at a baseball game, and we find that their average age is 20, we might also discover that 95% of them are between the ages of 6 and 39 years old. Now, our average of 20 is not as useful because many people are much younger or much older. We will measure the spread or dispersion of scores using techniques like the range, variance, and standard deviation. So, let's use these techniques to serve up our golf ball data and see if they are easier to understand now. I have created a bar graph with averages printed on it so that we can see our data more clearly. Now, what is the best golf ball? It probably took you very little time to determine that brand C flies the farthest. And you can use this data to make an intelligent, informed decision about your golf ball buying habits. Yes, brand C flies the farthest. but it's also the most expensive. Brand D, on average, flies 20 yards shorter, but it also costs 1/3 of what brand C does. So if you were like me, perhaps you might determine that the random human error of your golf swing means that extra 20 yards is really not worth the cost. If you were a pro player, on the other hand, in tournaments potentially making millions of dollars, those 20 extra yards could well be worth the cost. With good quality data, served up properly, we can decide whether it is worth the extra cash to buy a certain brand of golf ball. And this is what we want to do with statistics. We want to be able to serve up the data in a way that gives other people the opportunity to make the best decisions based on what we have found from our data.